Assalamualaikum, brothers and sisters.
Waalaikumsalam.
Okay, at least I know the function. The system is functioning well. Shall we?
Yes.
Sure.
Yeah. Okay, one more time. Assalamualaikum, brothers and sisters. Let's start our class today with the recitation of Kitab Al-Fatiha. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin, arrahmanir rahim, maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, as usual, we start our day with a recitation of a dua by Ustaz Alif. Tafadhal Ustaz Alif. Bismillah. Ustaz, you just come in, right? Okay.
والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين. اللهم ألهمنا علما نعرف به أوامرك ونعرف به نواهيك وارزقنا اللهم بلاغة فهم النبيين وفصاحة الحفظ المرسلين وسرعة الإلهام الملائكة المقربين وأكرمنا اللهم بنور علم وسرعة الفهم وأخرجنا من ظلمات الوهم وافتح لنا أبواب رحمتك وعلمنا إسرار حكمتك يا أرحم الراحمين.
Amin ya rabbal alamin. Syukran Ustaz Alif. Okay, you are now good in linear programming. Let's look at another peculiarity in this linear programming simplex method. Let's say we have this scenario: high-tech industry import electronic components that are used to assemble two different models of personal computers. One model is called Desk Pro and the other model is called Portable. And then high-tech management is currently interested in developing a weekly production schedule for both products. The Desk Pro generate profit of 50 ringgit and the Portable generate profit of 40 ringgit. And then for the next period of production, for next week production, they have allocated 150 hours assembly time for the two products. Each unit of the Desk Pro require 3 hours of assembly time. Each unit of Portable require 5 hours of assembly time. Then in addition, High-Tech currently has 20 portable display components in the inventory. So thus no more than 20 units of Portable may be assembled. And they have allocated a space for the warehouse. Only 300 square feet of warehouse space can be made available for the new productions. Assembly of each Desk Pro require 8 square feet of warehouse space and Portable require 5 square feet. Okay, you don't have to worry about the detail. Let's say it's done. This is the LPP model, the linear programming model. So maximize 50x1 Portable, Desk Pro, x1 is Desk Pro, x2 is Portable, $50 profit, $40 profit. And these are the constraints: 3, 5, 150 assembly time, x2, they have component up to 20, and then warehouse space. So if you are going to write this into standard form, you want to convert this inequality into equality, what do you do, brothers, sisters?
Add the slack and remove the inequalities.
Add the slack and remove the inequality. So let's say we are done in this case. So this is the standard form, we add slack for the first constraint. We add slack for the second constraint, S2. The third constraint, we put S3 here. The others, we put 0, 0, 0, 0. Okay, let's look back. We have less or equal to constraint, less or equal to constraint, less or equal to constraint, or less or equal to constraint. So let's test if this scenario, if we start at the origin, x1 and x2 equals 0, what happened to the other variables? Assume it's done for you. If we substitute x1 equal to 0, x2 is 0, we can solve the balance S1, S2, and S3, and this is the solutions. S1 positive number, S2 positive number, S3 positive number. What does it mean? We can get the initial basic solution. If any of this number is negative, what does it mean? We are outside the feasible region. We are not within the feasible solution. If we substitute x1 to 0, x2 0, we are making this into non-basic. And then the balance basic variable, if all of them are positive, it means we are within the feasible solution. We are within the feasible region. Let's say, suppose high-tech, in this problem, the management wanted to ensure that the combined total of production for both models would be at least 25 units. At least. So we have another constraint. At least combined total x1 plus x2. Take note, at least, that means not less, right? More than 25 units. So we are now having another constraint greater or equal to. Let's test this. So we have another constraint, x1 plus x2 greater than or equal to 25. The early one, less or equal to, less or equal to. The third constraint, less or equal to. The fourth constraint now is greater or equal to. When we write the standard form, let's say we write this way. So this is the first one. So we introduce another one. When it's greater or equal to, okay, 1 minute. When it's greater or equal to, we are going to subtract what we call surplus variable, SURPLUS, extra, surplus variable. Less or equal to, we are introducing slack variable. When it's greater than or equal to, we are going to introduce surplus variable. So the standard form become something like this, except that now at the last one here, we subtract the surplus variable 4. Equation number 4, surplus variable 4. Okay, let's see whether this is okay or not. Now, let's say now we have 1, 2, 3, 4, 5, 6. 6 variables, 4 equations. 6 minus 4, 2. Let's make 2 of them into non-basic variable. 6 variable minus 4 equations. 1, 2, 3, 4. So we have 2. Let's make 2 of them into non-basic variable. And what happened? We have S1 positive, S2 positive, S3 positive, S4
Negative.
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 What does this mean? That
So it
means
is
Out
beyond
of the visible region.
yes.
we are outside. That means 0, 0, it will be outside the visible region. That means we cannot get the initial basic solution. So what do? In situation like this, whenever we have greater or equal to, then we have another situation here, not feasible. That means S4 violate, because negative, violate the non-negativity requirement outside that means outside the feasible region. So what we do, we introduce another variable, we call it artificial variable A4, constraint number 4, A4, let's say A4 to constraint number 4. So this is just to trick the equations, to trick. This Ramadan, we cannot trick people, but never mind. This is mathematical trick to offset the negative value to enable us to find the initial basic feasible solution in terms of slack or surplus variables. So what we do, you look at the equation number 4, the last equation. Now we introduce negative s, subtract surplus variable, add artificial variable. So we are going to add artificial variable. We represent as A. A here represent artificial variable. Let's test. Now we have how many equations? How many variables? 1, 2, 3, 4, 5, 6, 7. 7 variables. And we still have 4 equations. So 7 minus 4, 3. So let's make 3 of them into non-basic. So the 3 of them, let's say x1 is 0, x2 is 0. Let's say s4 is also 0. What will happen? What will happen to the remaining variables? So s1 positive, s2 positive, s3 positive, a4 is also positive. So what does it mean? We
Within
are
Satisfy the visible region.
satisfy the feasible solution. But situation like this, at the objective function, whenever we introduce artificial variable, we are going to add a coefficient, very large coefficient, m, large magnitude. M represent for large magnitude of numbers. So introduce a coefficient of m only to the artificial variable and only to the objective function. So for maximization, we are going to introduce negative m, negative large number. For minimization, we are going to introduce a positive large number, large magnitude of number, m. It may say million, 1 million, whatever it is, but it represents large magnitude of number. So in the objective functions, we are going to write this way. The slack variable still 0 coefficient, 0 coefficient, 0 coefficient, 0 coefficient. This is for the slack coefficient. Once we have the artificial variable A4, we introduce, our case is maximization. Maximization, we introduce coefficient of negative m to the artificial variable. Yeah, we introduce negative m. Okay, so for less or equal, we add slack variable. For greater or equal to, we subtract surplus variable, add artificial variable. And this set, the earlier one is standard form. Now we are converting the standard form into tableau form. Once we have this artificial variable in the picture, in your set of equations, sometimes we refer this as tableau form. Standard form, tableau form. But sometimes we also refer standard form, this thing. But
Sir,
just, yeah.
sir, I have a question. If let's say all the variable before we add the artificial, all the variable are positive. Do we need to add artificial?
You will not get it, because there are some you will not get it, because there is some reason. We this artificial variable is just like the analogy in the textbook. It says if your battery is out, say you are having a car, your battery is, say, flat, no more battery running out. So what do? You get your friend's car, jump start using your friend's car battery, right?
Yes.
Yes. And then once the car, let's say everything, your car is in good condition, except that the battery only run out. Once you use your friend's car to jump start, your car will start, right? And then after that, what happened? You dismantle your friend's car battery from your car, right? So so the idea of this artificial variable is to jumpstart our iteration later on, to jumpstart, and this will disappear. Just like just now, I put an analogy: your friend's car battery, after you use it, then your car already in order, and then your friend's connections to the battery can be disconnected, and then you are on your own. Okay, brother.
Okay, sir. Thank you.
Okay, let's see how. So we have handled less or equal to, greater or equal to. Let's see a situation like this. Let's say we are given a constraint, something like this: 6x1 plus 4x2 minus 5x3 equals 30. It's already equal sign. So when we want to translate into standard form or tableau form, it's already equal, right? It is already equal. So what do? Leave it like that?
Maybe add the slash surplus and artificial.
Okay, let's see how.
But with coefficient 0.
Okay, let's say we start at the origin. Let's say we start at the origin, x1 is 0, x2 0, x3 0. What will happen? What's the value on the left-hand side?
0.
0. 0. 0 equals 30?
No.
Oh dear. So what should we do? So the left-hand side is not the same as the right-hand side. So we still have to do the mathematical trick. We still have to do the mathematical trick, even though it's already equal at the linear programming model or the formulations. Once you want to convert into standard form or tableau form, you have to do something also. You have to add artificial variable, say A5, to the constraint to convert the formulation into standard form or tableau form. The same thing here. So it become like this: 6x1 minus 6x1 plus 4x2 minus 5x3 plus A5 equals 30. So if we start at the origin, x1 0, x2 0, x3 0. then the mathematic become sensible. It makes sense, right? So if x1 0, x2 0, x3 0, what's the value of a5 here?
30.
30. Then the equation makes sense. So the same, once we have artificial variable in the objective function, you have to introduce coefficient of -m for maximization, +m for minimizations. Okay. Let's say another scenario. Suppose the management of high-tech has specified that the number of units of portable for X has to be less than or equal to the number of units of Despro model X1 after setting aside 5 units of Despro for internal use. Okay, let's say we formulate this one, no need to think about it. Let's say we formulate it this way. X1 to X2 after setting aside 5 units. So this is our formulation. We bring X1 to the other side. We have negative X1 plus X2. Then what do we have on the right hand side here?
-5.
-5. In Simplex, we are forbidden to have negative number on the right hand side. Or right hand side must be positive number. So what do? We convert this into positive. How do we change to positive?
Maybe multiply the whole equation with -1.
Okay, multiply the whole equation by the -1. Of course, this one change direction, right? The inequality sign will change directions. So good, thank you. So in here, we cannot allow in tableau form the right hand side values of the constraint cannot be negative. We cannot allow negative for right hand side value. So in here to convert, that's what brother said, multiply by -1 and change the direction of the inequality. So it becomes something like this. X1 minus X2 greater or equal to 5. So what happens when we want to change into standard form? When greater or equal to? Subtract.
Subtract
Surplus variable.
Plus artificial.
Plus artificial variable. Okay. So this is what the summary. This is what we are going to have. Whenever we encounter less or equal to, we just add slack variable. And at the objective function coefficient, we don't have to worry anything except adding 0 coefficient to the slack variable. When we encounter greater or equal to, we subtract surplus variable S and add artificial variable at the objective function. For maximization, we put -m coefficient to artificial variable, +m to artificial variable. When we have equal the linear programming model, say the formulation already equal, when we want to convert into standard form or tableau form, we add artificial variable. Once we have artificial variable at the objective function, the same thing, we subtract m for maximization, add +m that represent large number of coefficient for minimization. Okay, this one we have to remember. We will play around later. Okay, another thing is we have done maximization. We will do maximization involving all the less equal to, and then for minimize, also for maximization, you will go through greater or equal to or equal signs in place. So just remember, we are going to introduce surplus variable for greater or equal to, and then artificial variable just for equal to, equality. Okay. In minimizations, okay, any questions so far? No question. I think after we operationalize, then you know what it means. For minimization problem, for example, minimize costs. So the procedure is exactly the same, except that when you want to determine the pivot column, for maximization, we choose the greatest net evaluation index. For minimization, we choose the lowest or most negative net evaluation index. Okay, take note. For maximization, we take the highest, the greatest net evaluation index. For minimization, we take the lowest. And then the others is the same, like ratio is the same, find minimum ratio. Then how to know optimal? For maximization, how to determine optimality? When all net evaluation index is less or equal to 0. But for minimization, it's the reverse. The net evaluation, if all the net evaluation index greater or equal to 0, then we reach optimal solution. Okay. After we do, we can remember. Now we just theory. Okay, we do later this one. There are situations or special cases. No feasible solution or infeasible. In this case, infeasibility, just like in graphical method, it can occur. Infeasibility occurs when no solution to the linear programming can be found that satisfy all the constraints. Another one is unbounded solution or unboundedness. So linear programming is unbounded if the value of the solution is very, very large, infinitely large. Another one is we have more than one solution. It happens, linear programming can have more than one solution or alternative solution. Two or more optimal solution can happen. The last one, degenerate or degeneracy. That means the mathematical equation or the set of equation collapse. We cannot work. It doesn't work. That means the combination of equations doesn't work. Maybe we define the problem not correct, and we try to formulate the thing wrongly, and the whole set of mathematics doesn't work. So the linear programming is degenerate if one or more of the basic variables have a value of 0. Okay, what does this mean? Okay, I repeat this one. No feasible solution. Optimality conditions satisfied, but after you proceed, the artificial variable did not leave the basis. Unbounded, optimal solution not satisfied, ratios undefined. What is undefined? When ratio is less or equal to 0, that means negative or 0, we refer this as undefined ratio. any ratio that is less or equal to 0, we cannot consider this. We just ignore. Another one is alternative optimal solution. Optimality condition satisfied, but the net evaluation index to the non-basic variable equals 0. Another one, degenerate or degeneracy. Minimum ratio is not unique. There are ties. Okay, let's see. Let's figure out no feasible solution. What did I say just now? Optimality condition satisfied. Let's say maximization. So all this optimal. Optimality condition satisfied. But the artificial variable remain present in the basis. This is what it means. So this one satisfied, but this one doesn't satisfy. It should go. The idea of artificial variable is to jumpstart. But if it's still tagging with you, that means something not right. That means we don't have feasible solution. Another one, unbounded solution. What does it say just now? Optimal condition not satisfied. All ratios undefined. All. If you have one of them defined, it's okay. All of them undefined. So here we have ratio less or equal to 0. So what we do, we put a dash. Ignore. Anything you get 0 or negative, ignore. Another one, alternative optimal solution. Optimality condition satisfied, but the net evaluation index to the non-basic variable equals 0. Okay, let's see how it is. What's x1 basic or non-basic here? X1, it appear in the basis. X1 basic or non-basic?
Basic.
Basic. X2?
Basic.
S1?
Basic.
Non-basic.
Basic or non-basic? Is it in the basis?
Basic.
No.
Yes.
Not,
None.
not in the basis. So non-basic.
Non-basic.
Non-basic. So it's anything not in the basis, non-basic. S2 basic or non-basic?
Non-basic.
Non-basic. So if any of the net evaluation index for the non-basic variable equals 0, that means it's likely we have more than one solution. So this S1 is non-basic and 1 or 2 equals 0, even if S2 also equals 0. Even if you try to proceed, you can proceed. Let's say here, then it may go to one iteration, will move to another one. And then after that, you try to do further iteration, it will move back to this one. That means we have, that means the solution will be alternating. If you try to proceed, maybe x1 have a value, x2 a value, then you try to proceed, x1 have a new value, x2 a new value. You try to proceed again, it will go back to the earlier value. That means alternate. I don't show this one. Dr. Rafiqul's book last time they show. I think the Anderson doesn't show. Okay. The last one is degenerate. Degenerate. What does it mean? Minimum ratio is not unique. There are tie. So when we calculate ratio, let's say we have a ratio 25. There are 25, 25. Can we find the new pivot row from here? We cannot determine the pivot row. But some text, they say situation like this, you can still proceed, but choose the upper one first in the order. Choose this first one. But I tried this one. I think after that become messy. Okay. So these are cases. I don't have to go through this. I skip this one. I skip this one, and skip this one. Done. Any question? The class is not done, but the lecture on the basic, the theory part is done.
Sir,
Yeah.
degeneracy just now. If, for example, we have 3 bases and then one of it is unique.
The ratio.
Yes.
Then it doesn't generate.
Okay.
If one of
But
them,
what if the
the lowest ratio tie like this, that means
okay.
collapse. Even like the undefined ratio, was it undefined? This one undefined. One of them have a number. That means you can choose the one with number. We will go through this in our exercise next class. Okay. So this one. All right. So others, no question. If no question, I try to move on something else. We try to practice interpreting what we discuss. We are not going through very detail. We may not have the time. Just look at this. We have done this in the last class. You remember this one, this question? For is corporations. We have the idea how to do the iterations. We are going to do this minimization next class. And today, let's look into this one. What does it say? Solve the following linear programming problem. I think we don't have time to solve. Let's just practice how to write this into standard form. This one very easy. What do you do for the first one?
Add select variable.
Yeah, add select variable. So for the first one, I just put a note here, add select variable, let's say S1. The second one, and then equal something, equal 2,800. How about the second one?
Add S2.
Also add select. Why add? Why add?
Because less than or equal to.
Less or equal to. So less or equal to, so something, so 6,000. How about the third constraint? Is there others following? Only Brother Ashraf is saying.
Yes.
Okay, good. How about the third one?
So add select variable.
Also add. Why add?
Less than and equal to.
Less than or equal to S3 equal to 1200. How about the other objective function? Also add
add
S1,
S1,
add S2, add S3. Is it right, sister, brother?
coefficient 0.
Coefficient 0, 0 coefficient. Okay, just have a review. Okay, let's look into this one. Maximize Z equal to 4x1 plus 2x2 plus, sorry, minus 3x3 plus 5x4. Subject to the first constraint greater or equal to 50. The second constraint less equal to 80. The third constraint equal to 60. Now what? What do we do for the first one? Okay, just flashback. We just have the class. We cannot remember everything. Okay, the flashback. What does it say here? If greater or equal to, subtract, surplus, add
artificial,
A. For equal, only add
add artificial,
artificial. Less or equal, just plus as we did just now. And then depend maximize or minimization at the objective function. At the objective function, the coefficient or the artificial variable will be negative m, positive m, the same one. Okay, let's move back. Okay, now you remember already, okay, right? So greater or equal to, what do we do?
Subtract.
Subtract as, let's say the first one S1, then
add artificial
add
variable,
artificial variable, let's say A1, so equal
to 50.
50. The second one,
Add slack variable,
add slack variable S2. Is that all?
yes.
Sure. Everybody agree?
Yes.
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 80. How about the last one? No, we have equal 60. Okay, let's look back. Forgotten already. I also cannot remember. Equal. What do we do?
Or artificial.
Add artificial. Add artificial. So equal to, we already have equal to, add artificial variable. So this is equation number 3. I put A3. We don't have A2 here. Up to you. If you want to write A2, you must remember this artificial variable belong to which equation. So for me, to avoid confusion, let's say A1, S1 belong to first equation. S2, number 2 here, belong to the second equation. A3 belong to the third equation. Okay, now when writing at the objective functions, of course, I don't go to the extent of putting every equation in there, but I just want to highlight at the objective function here. At the objective function, whenever we have artificial variable and slack variable, we write slack variable first. And then we put artificial variable towards the end. Towards the end. Slack or surplus variable first, and then artificial variable. This is the way we write the order. So now we subtract S1 we have S2, then we have A1, and we have A3. So the first one, the second one, plus here, plus. Is it right?
So why the surplus is minus?
Good. That's why I'm asking you, is it right or not? Because no. So this is not right. This is also not right. This is also not right. This is also not right. Okay, let's look back. Once you put 0 plus or minus, make no difference, brother. But in order not to confuse us, we put the first one is, okay, let me follow. If we follow to, okay, back to pen. If you were to follow this one, the first equation, let's say we put negative, now back to negative, S1. What's the coefficient for slack?
0.
Come on, 0. So here, since it's 0, plus or minus mean no different. But in order to not to confuse you, let's follow this convention, because here is slack, because a greater or equal to here. The slack or surplus. We minus surplus variable. So let's say we minus surplus variable. And then A1. A1 is here. A1 greater or equal to, let's look back, greater or equal to. You put at the objective functions for maximization, our case is maximizations. What should we put?
Minus M.
Minus M. Minus M. So at A3, sorry, A1 minus M. And then S2, let's say just add it at 0. Okay, back to S1 here. As I say 0, you can put plus, make no difference. It's okay. You put plus or minus, it's okay. So S2 is alone. Then the third, here is the second one. The third one is for this one. What do we do? What coefficient should we put?
Negative.
Also minus M.
Also minus M. Why?
Maximization
Because
problem.
it's maximization. So this is how to handle when you are converting from linear programming model. Yeah, the formulations is the formulations. We are changing this formulation into W form. So we have to put all these things in place. Okay, no question. Of course, the same thing here, x1, x2, x3, x4, s1, s2, a1, a3 greater or equal to 0. You can put it there, but I want to save time. Okay, let's try this again, another scenario. Okay, what do we do on the first constraint? Let's look into this one. Minimize z. This one minimize z equals to 4x1 plus 5x2 plus 3x3, subject to all those constraints. Okay, what's the first one? What should we do? The first one? Greater or equal? minus,
greater than equal to.
yeah, greater or equal to,
Minus
so
the
minus,
plus
say
and
equation 1, I put
plus
1,
1
then
plus artificial A1.
plus artificial variable. How about the second one?
Plus
Oh,
S.
we need to multiply by -1 first.
This one sister say plus, is it? Plus S, S2. Brother disagree, sister. Why disagree? Brother say
The right hand side is negative.
right hand side is negative. You have to convert this. So in in simplex, in 1 minute, we cannot have right hand side value. Something. Let me check this again. Okay, no. We cannot have right hand side value. What do we do?
Multiply both by -1.
Multipliable. So we have to do some treatment. So x2 minus x3 less or equal to -8. So what do we do? To make
Multiply by -1.
the material. So we are going to remove this negative right hand side value because we cannot have negative right hand side value. So we multiply all by -1. So become minus x2 plus x3. What? Greater or equal to or less or equal to?
Greater or equal to.
So change the direction 8. Now we have this one. So what do we do? Greater or equal to? Add slack.
Minus plus add artificial.
Minus plus. Let's say this is equation 2. Add artificial A2. Okay, let's look at the third constraint. Already equal. Already equal. What do we do? Already equal. We just add artificial variable. So what do we do now? Where am I? I think I got the wrong one. Yeah. Everybody agree? Just add artificial variable.
Maybe we need to multiply -1 again.
Maybe. Why?
Because the right hand side is negative.
Right hand side is negative. So let's remove the negative right hand side first. So how to remove? So it was x1 minus 2x2 already equal -5. So we have to multiply with -1, so become negative x1 plus, right? Is it right? Plus
Yes.
2x2 equal 5. So when it's equal, what do we do? When we want to convert? Sisters? No, I don't hear sister. Say something, sisters. Add or subtract? Plus artificial variable A3. So this is done. This is done. How about the last one? This one you know already.
Add select.
Add slack. So now we have how many slack? So S4, S1, S2, S3. So let's write at the objective function first. S1, whenever we have slack or artificial variable, we choose all the slack as SS, slack or surplus. S1, then we have S2, then we have S4. Then only we write the artificial variable. We have A1, A2, A3. Then A1, A2, A3. Okay. Now, what coefficient should I put here at S1? I can maintain negative S or plus, doesn't matter. What's the coefficient here?
0.
0. Here, the second one, also 0. 0. I don't know what to do with the last one.
Plus M.
Plus M. Anybody disagree with sister? Sister say plus M. She
Yes,
said plus
plus
M.
M
Why?
is a minimization problem.
Minimization. Good, sister and brother. Thank you. So let's look back. For minimization, put plus M. Plus M. Minimization. Plus M. So we put positive M because it's minimization. Put plus M. Plus M. All plus M. Oh, interesting, right? Whether I have any more or not. Okay, we do this next class. Okay, we try this. Just verbal. Okay, no interesting verbal. Okay, this one only 2 variables. What do I do here? Plus or minus something?
Minus.
Minus.
Surplus. Add artificial.
Surplus add artificial. Let's say A1 equation 1. How about the second one? The same.
Oh, the same, yes, the same.
S1, sorry, S2 plus A2. The third one?
Add slack.
Add slack. S3 belong to equation. So now we have 3S and 2A's. Let's write down S first. S, 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 A at the objective function. So which one? S1, S2, S3, A1, A2. So let's say plus, plus, plus. What's the coefficient? I know you are
0.
I don't mean to insult you, you know, but just for learning so that we remember. So here 0. This one? 0. 0.
S.
No, I do not know what to do with this A.
Plus M.
Y plus M?
Minimization.
Minimize. Here you say minimize. So the same thing here. Also plus M. Okay, now you are very good at it. Any more? This one we can do after doing next practice, you can do on your own. I think we are done. Okay, any question? One minute. Want to do something first. No question.
No.
No question. But we cannot go home, you know. You're already at home. But you cannot. Okay. If no questions, I'm not ending the class yet. I just want to ask who started the project work? Everybody started? Every semester? Yeah.
Yeah.
No,
Yeah,
yeah. So we are going to do late start, right? Nobody early start. Okay. If I were to do a project, I think from past experience, before too late, sometime on the last hour, student ask me how to get data. I cannot get data, sir. So I tell them, cannot get data, what to do? Cry? Okay. Let's ask Sister Erna to show us how to find data. Okay, Sister Erna, can you try put your face on and then try to share some screen? Okay,
Yes.
share your browser. Can you share? Try.
Yes.
Okay, we don't see yet. Sister is sharing her browser. Okay, let her go through for us, walk through how to find data. How to find data, sister? Should I just cry? No, or
Oh,
sister?
no.
No.
You can
Okay. Okay, let's
just click.
find Ministry of Finance. Okay, sisters, show that. Let's try Ministry of Finance. You can have Malaysia or Singapore or other country. Let's for us, we just find some information, whether any information from there, no? Ministry of Finance or Kementerian Keuangan. Then from there, no data, just wishing us for buka puasa only. There's nothing there. What to do? Okay, sister, can you help us how to find data, sister?
We can just
Oh.
find the data at the archive.
Archive, okay. The
And then
archive.
the economic report.
The economic report, data economic. Oh, so many of them. There are so many.
Yes.
Now we choose
Yes,
the latest. Let's say we choose the latest. Then what are the information we want to look for? Let's say
statistical table.
Okay, statistical tables. Let's say, what do you want to show us? Prices. Okay, let's look at prices. Wow, lots of information there.
Yes.
Okay, hold on, sister. Let's say we want to do the project. Let's say we choose an idea after you sit down together. Okay, let's do forecasting. Let's do trend forecast. Okay, what are we going to forecast? Let's say we look into forecast like, let's say, food prices. Let's say food prices. Food prices. Then these are the index. How's the index going? Just not the top one, sister. Leave it there first. The top one, the food price, the index. Leave it there first. Let's say we want to say food. Okay, leave it there first. Then you see there 3.6, 3.9, 4.0, 1.6. That means the older one is smaller number, go up and up and up. Let's say you do a forecast on food prices using, say, trend or regression, whichever. it is not done for me. If you do like that, it doesn't give any meaning, just to show me you know how to do forecast, but it doesn't make it meaningful. But how to make it meaningful? Let's look into the prices. And then let's say you look into, you forecast income for new graduates. Look into index somewhere. No need to search, sister. Say income for new graduates, whether it increase at the same rate or not. That means if it doesn't increase at the same rate, that means you are getting poorer and poorer and poorer as time passes by. Then you look into prices of apparel, for example, say clothing. Then if the prices go up and then your income doesn't go up, doesn't commemorate. So the prices of clothing rise much faster than your income. So what? So we don't buy dresses for many years, many times. Okay, sister, show other thing you like to show, like a sport, all this thing, sister. Just scroll down. Yeah, go on. Consumer prices. Okay. Any more? Just highlight to all of us. And so you don't have to worry. Data is always there, and then up to you to play around with this data. Either you want to use linear programming, let's say plantations, how the country spend planting oil palm, coconut. And then you can use that as a basis for your research. Okay, anything brother want to ask? Brothers, sisters, class. This is just to highlight one way of getting data. Unless sister want to show us more, okay. You are welcome, sister. You want to show us more?
Yeah. Yes.
Okay. Okay. This one, producer price index, storage, processing, the sector, which is agriculture, mining, manufacturing, electricity and gas. There are lots of informations, but I don't expect you all to take all this. Just pick some that you think suitable for your group's work. There are too many for you to select all this. This is the work of the Ministry of Finance, but not for our project work. For our project work, maybe you look into manufacturing. Okay, let's say manufacturing. You look into manufacturing. Let's say if it is increasing, what does it mean? Local are not going to go there. And then you find the migrant workers, for example. The more manufacturing, I think there will be an increase in migrant workers also. So there is some relationship. And then also when there are more migrant workers, you have to check whether at the crime rate, look into crime rate. I think you can check crime rate from the police information. I do not know. And then see how does it relate? Are there any relationship or not? Or maybe no, maybe yes. If no, that means the crime is not attributed by the migrant workers. Maybe by by the local people also. So these are something that you can think of. Don't follow me exactly because I'm just throwing opinion, but maybe your group prefers something else, by all means. Any other source, sister, you like to share with us? No. Okay. All right, good. So any questions? You can search, not necessarily local. You can also, you want to have more information here. For example, like sister now show up to 2019. You want to have older one, you can go to the older report. The older report will reflect on the, let's say now 2019, you look into 2015 report, then you can have a backtrack for 8 years. You have 8 set of data. If you need more information, you can put together all this information. Yeah. Everybody, any query, any questions? I hope it helped. Hello, anybody down there?
Yes.
Yes. Yeah. Okay. It's done then. Okay, you stop sharing, sister. No. All right. Any other questions? No question. Give you some thinking about what to do before too late. I just realized that we have not much time after Raya, and then now Ramadan. After that, Eid. After that, we are going to enjoy ourselves. And then you are struggling to finish your report. All right. If there isn't anything, can I end our day today?
Doctor,
Yeah.
for the PBL assignment,
Yeah.
yeah. The chapters, we have to choose 2 chapters, right?
You have to choose something that interrelated. If not interrelated, it's okay for you to choose one.
Oh, I see. So,
But
based on your guidelines, number 7,
to any minimum 2 chapters. Is it?
yes, the combination of topics too. So
Yeah.
we can choose, let's say, smoothing methods plus linear regression, like that.
You may not can, yeah. Smoothing, not so. It's best regression. One is sufficient regression.
Yes.
What I mean by that, more than 2, if you choose, say, linear programming, graphical, and then after that you look into, say, simplex, graphical 2, and then we have more than 2 informations. Something like that, you can use 2. But if you use smoothing and trend, it doesn't match. But you want to look at trend and seasonal, it match. Because there is an element of trend and element of seasonal, say in forecast, for example. So situation like that, you can use 2 topics from the same chapter, or anything that you think it match from 2 chapters. Just to choose a topic, not the whole. If one chapter, let's say project scheduling, you cannot do both CPM and PERT. Maybe just use PERT only, let's say. Do I answer you? Not
So
really.
it's not compulsory to choose 2 topics.
Yeah. Not okay. Now I just impromptu here. I think not so critical, but not so simple. For example, as I said just now, you say forecast, say you use regressions. But you use regressions, you must know to choose which are the element to put in regressions. Maybe you try to have more than one item to forecast, and then look at the relationship. Just now I give an example. If you choose prices of food, prices of clothing, income, and then increase of population, does it match or not? If the increment is about the same increase, that means the quality of life of humankind in future, even yourself, will be okay. But if there is some disparity, some increase faster than, say, your slope after you do regression, the slope of, say, price of, say, clothing, much faster than your income increase. Because the average increase, there is also some information there about income. If the income, then the income increases slower, then you can make a write-up. I think you make a recommendation. The government had to do something about controlling, say, prices of clothing, prices of food, because the prices, I mean, your income doesn't match, or make the government institute this compulsory increment rate or whatever, as if you are a consultant to the government. You can do some write-up, make that recommendations. Of course, not as simplistic as what I'm saying. I'm just giving some key points here. Okay, brother.
Understood, sir.
Again, I think one brother asked me about how to write. I think this is privately asked me, not on this project. I just have to say this, in academic, you have to, like rubber band, you have to stretch the rubber band as long as you can. That means small point, small issues, but you have to be able to write up. I mean, you do a lot of discourse, talk a lot. But in business world, I think that's done by somebody else, the write up. But if you are the manager or general manager of a company or director or CEO, you are interested at the bottom line. What is the bottom line? That's all. You are interested at the bottom line. And furthermore, in writing in business world, you are trying to compress, make it simple, succinct, so that the CEO don't have to spend a lot of stories, but just pick up the main informations. But in academic, you have to expand, no choice. That is the criteria of academic. Once you go into the industry in future, you will undergo another psychological experience. Now the business, the bosses want to have all bottom line, summary. That's the reality. Okay. All right, brother, sisters. Sister Anna, any more question? The others? Sister Sristi, quiet. Okay. If no other issues, can I end our day today? Let's end our day with the recitation of Suratul As. Bismillahirrahmanirrahim. Wal as innal insana lafi illa allazina amanu wa tawassaw bis sabr. Thank you very much, brothers and sisters. See you again. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, Doctor.
Welcome. You're welcome. More welcome. Who is that little boy?
Oh,
Welcome.
again.
Thank you, sir.
Welcome.
Doctor.
Most welcome. Okay, I end
Yes,
now. Okay, I end the meeting now. Assalamualaikum.